Cool.
Yeah.
So
And, oh,
everyone is okay with recording, yeah?
yeah, absolutely.
Cool. Okay, so let's start. I'll share my screen. Cool. So I'm not as prepared as it might look. So 1 second.
Don't give it away, man.
Okay. Yeah, I just need to get rid of the Zoom. 1 second.
Zoom always gets in the way.
Yeah. Cool. Cool. So going right into it, we're gonna review the message passing in CBC Casper. So CBC Casper is a family of protocol. So it just describes pretty much a protocol that everything else that you build on top of it will need to have these properties that you described in the abstract Casper. So a lot of the stuff are undefined as we look when we go into the estimator part. But the things one of the things that is defined is like the messages and what they need to hold. So we're gonna have a message with a value that the validator proposes, the validator, the justification. And the justification is pretty much the state that the validator is in. So that's like a set of messages that the validator is in, and his new message is an extension to those messages. And the reason we use justifications are basically there's no notion of time in this asynchronous protocol. So the way that we can have kind of like an order in this world is to just say, well, this message is based on that message. So we know that this message happened after the other message. Does that make sense?
Yeah, totally. I like the explanation of justification kind of being like that validator's state that they're going to propose a message from.
Cool, awesome. So here's let's see some examples. What is a state? So we're gonna start with like a no state. So we have the empty set, which I noted as null. And then your first message options are, if you have two validators in a binary consensus protocol, is either validator A sends a 0, and the justification is null, because or B sends 0, or A can send 1 and B can send 1. And then we're transitioning to these following state options. It's either no one's seen any message, because no one sent a message, technically. That could be an empty set again. Then you can send all these previous messages that we mentioned, or we can send or we can be in a state that we saw two messages, and that's just kind of a combination of the messages we saw before. So then when a validator wants to send a message, it will send a value and a justification based on the previous state. Like any one of those states will be a valid state for a validator to be in. So that might be a bit confusing. So if anyone has questions.
I think I think I get what you're trying to say, but I also think, do you I could probably help you do this, and maybe we can do this together later on, Drawer, is create a visual on
Hmm.
what it will look like if all the different people are like at a null. Just show like, all right, this is what the justification will look like. Here's what the message will look like when it's like the initial one and things like that, and go from there.
Hmm. Sure. So for this slide, the idea is to make sure that um, the state transitions just becomes it's just based on messages that people saw before, and you in every state you just have more options to add to that could be the state at the moment, but you never know, because you never know which messages arrived to which validators. um,
Yeah, I think Vlad likes to refer to that relation as the superset relation because you're always kind of building up more messages based on the previous stuff.
yeah, that totally makes sense. So let's go to I can never say it right.
Equivocation.
Equivocation. Okay. I'm just gonna blame it on the time, but it's probably not, because I only read it and I never say it. Anyway, so basically, um, uh, that would happen just when the two messages from a validator, you see two messages that don't reference each other in their justification. So it's either you see a validator with the same justification but with different values. So that means the second one of the messages was supposed to kind of build on the previous one, but it doesn't. Or you see a validator that send the same value, but with two justifications that also don't reference each other. So I believe that's the two cases that could be.
Yeah, absolutely. And just to add a little bit to that, right? Like since it's in an asynchronous network, we can never say whether someone has received a message that we sent, but we should certainly receive the messages that we sent. Otherwise, like what exactly is going on here? So this is just kind of ruling out that situation of myself sending a message and then turning around and saying, oh, I didn't send that message.
Totally, yeah. That's what yeah. So cool. Next is the estimator. So we talked about the messages, but then how do the validators come up with the value to propose? So the estimator is going to be a function that basically looks at the state of the validator, and he derives a set of values that can be chosen for that message. If a validator, if a node sees a message, it runs the estimator on the justification, but the value in that message is not in the set of the values, then he knows it was an invalid message. The estimator itself is undefined in the abstract and minimal CBC Casper, and this is mainly because it's unique for the type of consensus protocol you derive from those families. So in the binary one is going to be different than the integer one, right? Because you have different types of values and different types of deriving those values from the justification. So here's just the definitions from the paper about what are consensus values. What is the estimator function? Obviously, it's not showing well. Let me just, for some reason. Yeah, cool. Cool. So I just kind of copy pasted the definitions and the explanation. Anyone wants kind of like to go through the definitions, or is that okay?
Yeah, that's good for me.
Yeah, but curious question. So in terms of like receiving the estimator, now I think we worked on this with Tomislav a couple weeks back, and maybe I'm like jumping too far ahead here, but is it true, like for instance, if you just joined, like are you being, is it like binary kind of like auto assign your own like estimator, or is it just like assigned to you based off the formula?
So it's a protocol, like the consensus protocol. So you can change it, right, on your node, let's say, and have your own estimator. But then everyone else in the network, if they're not running the same estimator, and they will not arrive to the same consensus values you're arriving to, they will say you just having invalid messages. And in some places you might get slashed for it.
But then but like how will you even, I don't know, because I know like before when we drew it out, we just kind of assigned everything like in a controlled environment. But I'm just curious to know how, when you join, is that when you then look at the Genesis people or the Genesis validators and say, all right, well, all their estimators are at, let's just say 3 or something. So I could set mine along that same variable.
Right. So the estimator as well is just a function. The value that you derive is based on the justification. So you join and you keep getting messages, right? So you're starting from the Genesis block, and then you keep getting the other blocks, and you're getting it through messages that have justifications, and then you start to, like, your state starts to progress. And then when it's time for you to send some messages, you're gonna base them based on what you've seen. So when you have your justification, you're going to run it through the estimator, and then you will have a set of values, and you might need to just randomly pick one of those values and attach it to the message. So you shouldn't worry about joining a network and proposing the wrong value, as long as you're running the same software as others. Does that make sense?
Yeah, that does.
Cool.
Yeah, so one question. So when you join the network, does it just start you off with like the default estimator or something? Or do you choose it?
So the estimator, you mean the function itself?
Yeah, exactly.
So that's in the code.
Okay, right. But you said that you can actually change it?
Well, you can change your source code, right? And you can run a different software. But then people will know if it doesn't estimate the way it's supposed to estimate.
Right. Well, yeah, because you'll just have invalid messages.
Yeah, but also keep in mind that for other validators, you can run the estimator function, but you only can take as an input all of those justifications that you've seen. And that means that validators are able to just ignore messages or other blocks they might have seen, but they've not given any kind of, they've not included so far in the justifications. So they can have a different estimator function. They might be compatible to what others have seen before.
Okay, I think I see what you're saying.
Are you talking about the function itself, or?
So you could modify your client code such as that you are not making your decisions based on what you've seen, but rather also include the options that you're just making valid, you're just proposing valid blocks, for example, based on what others, or based on your justification so far. And that might be something different than just running the estimator on all blocks or all messages that you've seen.
But the estimator itself, right? As long as it needs to derive, it needs to output values that others running the same justification will also derive, right?
Yeah, exactly, and that's what I was saying.
Oh, okay.
So you basically can modify your client code such as that it outputs a valid a value, but it's not necessarily what that's not necessarily the output that, for example, would be the fork choice if you include all the blocks that you've seen so far.
Right. I see. So as long as your estimator outputs a subset of other estimators, then you're fine.
Yeah, exactly.
Right. Okay, cool. So here we finishing with the estimator. So I told you guys it's going to be hopefully short, and was, and then I don't have a drawing app at the moment. Definitely wasn't as prepared as I wanted to. But if Isaac want to redo some, actually I had some other. Okay, sorry. I definitely didn't put that slide in the right place. The next time should be later. Okay, so let's go to using the knowledge we gathered right now, which is not much, but let's go into a consensus protocol, and we'll start with a binary Casper. So this is pretty much what we've done in the previous sessions. We can see the score function, which is sum of weights of validators that propose that consensus values. So we have 0, 1. So we're going to sum up all the validators, the weights of all the validators that said 0. And then we're going to sum up all the validators that said 1, the weights of those validators. And then we're going to choose the max one. Should we switch to you, Isaac?
Sure. Yeah, you want me to go through binary consensus?
So if we can do, I mean, do you want to do the drawing again? Or
sure. Yeah, we can do a drawing.
That was
yeah. I can share my screen since I already kind of made a drawing already. Wait, Isaac, do you already have a drawing?
Sorry. I don't. I was just going to start from scratch, but that'd be great to start from one that's already going.
All right, here's the one that I was working where I kept coming to consensus. So let me share my screen. Ba-ba-ba-ba. All right. And we do that.
That's already so much nicer than what I was going to do. So thank you.
So on here, so we all started off everyone with the weight of 1. So we got John, Bob, Joe, and Alex. So for John, he started off with his trying to get the grammar right here. This wouldn't technically be the estimate. This is what he predicted the blocks to be, or the blockchains to be.
Wait, so we're doing list consensus here, right?
I think we're doing binary, right? Or
It depends. It depends, because if that displayed block there like 1,3, that could be the estimate, which is kind of how we've been showing it, and it looks like that's a list, so like 2 values, right?
I didn't put them in like their curly brackets, which I should probably do.
Okay, so what, I guess then the question is like, what exactly do you mean by the 1 and the 3 under John?
So this is like me talking to get the grammar right. Sometimes I have to like come through, but yeah. So in terms of like, so this would be, you say, defined as a list in binary, or this would technically be the estimator since they're guessing 1 and 3 for that blockchain.
Yeah, so those as estimates are just fine, and we would be doing the list consensus here, and it looks like, maybe just like a list of integers or something like that. So like 1,3 would be a valid list of integers, as an estimate in this, especially since there's no justification too, right? So it's like automatically valid.
So the first one that I started off was Bob. So he saw John himself, obviously, and Alex. Now, what it comes down to is he's taking the first number of the 3. So you got a 1, 2, and a 2. Well, even though they all have the weight of 1, so they're all the same, they're outweighted by 2. So that means the first number for his new consensus is 2. And then it carries out for the second number. So you have 3, 3, and 4. The 3's outweighs the 4, so it's going to be a 3. Now, to kind of swap it up here, let's just say Alex, that might be going a little bit too far, so Isaac, stop me whenever. So let's just say Alex, well validator, and she has the weight of 3. Now, this is where, correct me if I'm wrong, so even though the 2 outweighs or has a stronger weight than the 4, but since Alex has a stronger weight, if I'm saying this right, this will actually be 4, correct?
Yeah, so we would we would score each of those values. So like 3 for being the second entry that we're talking about, right? So then here 3 would have a score of 2 because John had a score of, a weight of 1. He proposed 3. Bob had a weight of 1. He also proposed 3. So that's an ultimate 2 score for that value being a 3. And then Alex has a weight of 3. So her proposal of 4 for that entry outscores the entry of 3. So then we would actually end up with a 4 there. So that's absolutely correct.
All right, cool. So let me just change this back to 1. Oops. Yeah.
Where did you guys get the list consensus?
We started talking about it last time. I mean, it's almost the same thing as it's almost the same thing.
Did you guys came up with it, or you saw it somewhere else?
Well, so they do consensus on real numbers and consensus on lists of real numbers, integers, whatever you want, really. I'm not 100% sure what information exists on their GitHub, but supposedly all that information is on the GitHub. I haven't personally seen it, but this is basically just coming from discussions that Joshie and I had, and then what we were talking about last time.
Right.
So we've kind of extrapolated a bit from the binary consensus.
Yeah. So the reason I wanted to do binary consensus, and maybe only with like 2 people, is for us to write down the justifications as well. So we can kind of see how the state develops.
Yeah. Okay.
In the validators.
Right, because up until this point we've just been writing them with the arrows graphically, which is nice, and you can kind of see visually what those justifications are. But yeah, it'd probably be a good idea to actually write it all out. All right, Jeremy. So cool. Yeah, definitely agree that Bob's second block there should be the 2,3 that it is.
Awesome. So going down to the next part. So this is for Bob. So as they start to all get synchronized here, so let's just say Joe's the next one. So obviously he sees himself, which is 1 and a 4. Which is a 2. Yeah, this is on my screen. Yeah, 2 and a 4. So as it comes down, so now as we look at these, so we got a weight of 2, which they all voted for 1. So the first number is going to be 1. And for the second number, you got a 3, 1, and a 4. Now, here's another tricky part, and Isaac, maybe you can help out with this one. So even though they all did not come to a consensus on a second number, who then dictates that second pair?
So technically they can choose any value that they want as long as they've seen that value. We discussed this a little bit last time, and basically what we were saying is if they're not choosing out of values that they've seen already, there's no possible way to come to consensus. So that would be a terrible estimator. But if they've seen the value, then we can guarantee consensus. So as long as they've seen it, they can put it down if there's like a 3-way tie, So there's a 3-way tie.
Who wins that though? That's the thing.
Well, right. So Joe decides basically.
All right. So it's really okay. Cool. Because I was like, let's just swap it up here to see what happens, and
Right.
I changed it to a 4 instead of a 3 because then everything will come down to the 2-3 at the end of the day. So,
Okay.
all right. So we're gonna stick with 4. So Joe decides, what, screw it. Let's go with Alex's number 4, just be different, and goes down to the next one, which is now the same thing. So let's just say Joe wants to do another one. He sees John's recent one, or no. Wait, what would be a good way to say this one? Yeah, so let's go to John. He wants to propose one. So he got himself, Bob's recent one, and also Alex's recent one. They came down to the consensus of 2-3 for the same methodology we used before, which now enables Joe to come up with his new number. So we have 1-4, 2-3, and Alex's 2-4. Obviously, the 2s outweighs the 1, and the 4s outweighs the 3. So this new block is 2-4. And this is where, without getting too skewed, it will start to get confusing because the only plausible way of someone to disagree on an already proposed or to disagree on a block that you already agreed with is we'll have to come down to someone, or I think a block coming to a tie as we saw in Joe.
So Jeremy, can we talk about that last block for a second?
This one?
Yeah, that one, exactly. So with this block, Joe has effectively seen the entire DAG. So Joe has seen all of the messages that have been proposed, because even though there's not a direct link between Bob and Joe for that one, there is an indirect link through John's latest message. So if we were to go just to the previous block, yeah, that one, the 2-3 from John. So Bob's message is referenced in that one.
Mm-hmm.
Yeah, so Bob's 2-3 estimate is also going to be factored into Joe's most recent block.
Oh, okay. So if you were to write this out, let me see if I can insert this.
But the point is, no one knows that actually Joe has seen the block, so it is not an invalid message if he would ignore it.
True, right.
That's
Yeah,
the
that's a good
point I
point.
was making earlier.
Okay, right. So yeah, you're kind of saying just like pick and choose to get a value that may not come out as the value you would get if you were to look at all of the messages available to you.
Mm-hmm, exactly. I mean, in this kind of diagram, we assume that that Joe has seen the message because it kind of is denoted as a later block here, but
Right.
that might not necessarily be the case.
Okay. Let me ask this question. Mm-hmm. So I think this is important. So if Joe wants to reference John's latest block, then Joe must also acknowledge Bob's latest block because it's in the justification of John's latest block, correct?
Yeah, so my point was if he would ignore John latest blocks.
Right, yeah, absolutely.
If he makes a justification to the block, then obviously he can't say that he hasn't seen the block.
Right. Okay. Cool. Just wanted to make that really clear.
So would it be like, for instance, for this one, I might totally be writing this out, well, just so I can understand. So John, in his latest block, he will see the messages for I'm trying to figure out how I can write this out where it kind of makes sense. Cause I kind of follow, but it's not yet clicking to me yet. So because Joe Joe already has the latest blog. No, John already has the latest blog that they all agreed on. So all the messages from Bob, John himself, and Alex are already in this one, or will already be in this one.
So yes, because that block is including in its justification directly the latest block from Alex, the latest block from Joe, and the latest block from John. But John's latest block includes in its justification the latest block from Bob. So effectively, Joe's latest block references everybody's latest block.
Mm-hmm.
Does that make sense?
I think I'm following. And so what will happen when they like finally meet though? Because as Joe trying to propose a new one, so then he just acknowledges, say, all right, I will automatically be a good actor and just say I should just change mine, or should I update it to 2-3?
Well, so it turns out that since they all have weight 1, right, and 2 of them are proposing 2-3, one is proposing 1-4, and one is proposing 2-4. For the first entry, we have a weight, a score of 3 for the entry 2. So that one's definitely going to win. It has 75% of the weight already. And for the second entry, we have a score of 2 for the entry of 3 and a score of 2 for the entry of 4. So we really could put a 4 or a 3 in that block, or in the second entry, right? So your list there, 2, 4, is definitely valid, and also the list 2, 3 would also be valid.
Oh, okay. Okay. Now I see what you're talking about now.
Okay, cool.
All right.
Cool.
And I don't really know where else to take it from here. Dora, is there something else you think we should add to this?
No, not really. Cool. Do you guys want to do the integer one? Because I don't think there's a time to do both.
Yeah, we can do integer consensus if you want.
Cool. So let me show.
Oh yeah, you have something prepared for it already.
Not really, but I just want to go over the estimator because I think we did it differently than the paper.
Oh, okay, okay.
Yeah, so that's the binary. Cool. So the integer consensus. So we did just like whichever integer has the biggest weight. The paper suggested the estimator to be a weighted median.
Okay.
I kind of try to explain it in simple words. So yeah, the score function is as we did it, so just like the weight, the sum of weights of the validators choosing a specific integer. But then the estimator is a weighted median, which is a set of values that half or less of the sum weight is above and half or less is below. So I think I got so you can see it over there. So basically, we probably need to wait or get the weights of all the integers, and then find the ones that any integers greater than them have the sum of weights of all the integers the sum of the weights of all the validators together, half of that or less. But also, okay, I think we should just do it and then we'll try to calculate it.
Well, can we go back to Jeremy's screen and talk about it there? Because we're almost doing integer consensus, right? We just had multiple integers we were coming
okay, so okay, cool.
All right, let me take back over. And I think you totally gonna have to guide me on this one, bro.
Yeah, no, this is interesting. I haven't seen this weighted median definition, so I also want to understand it.
Sure, yeah. Let's change the weights of the validators to have random ones. Cool. Yeah, that's fine. And then change the values to maybe just the first one in the list.
Okay, so you're saying just to have one entry.
No, yeah, but like we can keep them, right? Because we already did the consensus on them.
Yeah.
So you wanted to change this one?
But we changed the weights. We changed the weights, so it's gonna.
Yeah.
Okay. Yeah.
Well, how about let's just look at it with the list, and we can just talk about each entry.
Right.
Yeah, you might need to.
We have to have one entry though.
Yeah.
So Jeremy, can you just like have one entry in those boxes?
Also, just get rid of these guys as well.
Yeah.
Let's just delete all of those estimates, and we'll just fill in some values.
All right. So I just do this. Think I should just leave this one, or you just completely want to start from scratch?
Well, we just want a single number there. So like you just like leave 1 in there.
All right.
Yeah. So maybe, you know, like for example, you know, maybe Bob has like a -2 and Joe is proposing, you know, a 17 and Alex is
You have
proposing.
negative integers when you're doing it?
Oh yeah, definitely, man. That's what integers are, right? They're whole numbers, 0 and negative whole numbers. I guess when I say whole numbers, I mean counting numbers, right?
Let's see here. Let's make this like 9 or something.
Yeah. Okay, cool.
Okay, so Bob, right? So he gets 1, -2, and 9, right?
Yeah.
So we're gonna. So.
Oh, wait, to make this a little more interesting, do we want some of their initial estimates to be the same?
That's what I thought as well. Yeah. Does it
Yeah,
matter
alright.
really? Though you're just gonna combine.
Well, I think it would be more interesting because like we're definitely coming to consensus on 9 in this one, right? Because like,
right. Yeah.
well, okay, maybe not. I don't know.
No, because yeah, the weight.
No, I think we are because everybody's proposing different estimates, and Alex has the most weight, right? So Alex wins.
Oh no, because it's the average median, right? So it's actually not Alex. Pretty sure.
Okay. All right. Cool. Yeah. Let's do it then.
Okay. Okay. So we have a -2 with a weight of 3. Right, and then we have 1 with the weight of 1.
Mm-hmm.
And then we have 9 with a weight of 7.
Right.
And then 11 with a weight of 5. Cool. So the sum of weights is 16.
Yeah.
So the half of that is 8.
Right.
Cool. Do we have a value that all the integers are above it? So I guess yes, you're right. Right. It's gonna be Alex in this case.
Remind us again what we're looking for here exactly.
Right. So we're looking at a set of values that all the values above them are the weight is less than half of the sum of all weights, but also all the values below them, the sum of the weights are below half.
Okay.
That's the definition. You can just recheck the paper 1 second.
Mm-hmm.
Yeah, so we're looking for a value that for all the values below it, their sum is less or equal to the half of the sum of all values.
Yeah. Oh, can we do something really interesting here? Can we change some of these entries? Would anybody be opposed to that?
Sure. I'm kind of curious to know, like, what would happen if, let's just say Joe got involved, and since technically his number is higher than Alex's, would he technically win?
Well, his weight is smaller though.
Yeah, but actually, yeah, if you put the if the value is lower, wait, maybe
Can you open up once more the estimator function?
yeah, I want to look at it as well. Let me share, see if I'm cool. So here we are. So we're looking for an X that for all the X's that are less than it. Now, I have a feeling maybe I'm misreading this part, that it says the weight needs to be less than half. Oh, okay, yeah. So I think, wait, let me see if I,
Yeah, it looks like, what's written there, not that I can say 100% understand it, but we're saying like, okay, we're going to take each one of these possible values that we're seeing, and we're going to compute this, sum of weights for these numbers. So like, for example, we saw the number 9 in that estimate that we were making. And so we want to look at all the other estimate values strictly less than 9. So in this case, that would have been -2 and some 1, I think, were the other two values. I don't remember. But we want to do the sum of the weights of the validators that sent out those values that are strictly less than 9. And we want to see that sum of weights is less than half of the total sum of weights. And then do exactly the same thing for all of the values that are strictly larger than that estimate 9. So in our case, that would be 11 was the only one. And I think that was from somebody with a weight of 5, which is definitely less than half of the total weight.
yeah. So the only thing that confused me is kind of the gap between the first sum and the weight function.
Oh yeah. I think that's
just what throwed me up. But I think I was yeah. So you agreeing with what I was kind of.
Yeah, and that spatial gap there, right, is just coming from the massive string of symbols under the summation symbol.
Yeah, that's okay. Cool.
Yeah. And yeah, because of latex, formatting.
Fair enough. Yeah. Cool. So I'll stop my share. Is that okay, Phil?
Yeah, thanks. That matches my intuition of a million.
Cool. So if Jeremy wants to put back his
Okay, so in that median, right, that capital X, that's like the set of all estimates that we've seen. So like we're talking about Bob's second block here, right? And we're trying to figure out what Bob should estimate. And the set of estimate values that Bob has seen at that point is 1, -2, and 9.
Oh,
is that correct?
Oh yeah. So Bob didn't see 11, and we calculated 11. You're right.
Right. Bob, currently as drawn, Bob didn't see 11, and I think we just shouldn't change it so we can continue with that assumption.
So, no, so if Bob didn't see 11 though, right? Does it affect us?
Well, so let's see. So we're trying to compute that median stuff, right? So let's first look at the value 1, right? So that's an estimate value we've seen. So let's look at that value. So for 1, there are no estimate values that are strictly less So definitely we have less than half of the weight for that value, right?
Mm-hmm.
Okay, so we definitely satisfy the first criteria of that weighted sum. So what about the second? So all of the values that, oh, sorry, oh, I'm an idiot. -2 is definitely less than 1. So let's do that calculation again, right? So the only value that's strictly less than -1 here is than 1 is -2. -2 is coming from Bob, who has a weight of 3. So 3 is the sum over, all of those values that are less. And we have, okay, so 3 is definitely half, less than half of 16, right? Which is 8.
Oh no, but
So,
now it's 11, right? 11 divided by 2 is 5.5 is the half.
wait, so we're
'Cause we-
only looking at the weights that we've seen?
I guess so, right? So actually it might be from all the validators. You're right.
But if it's from all the validators, then it might get stuck somewhere.
No, but we don't have values from all the validators. So you have okay.
I mean,
You're right.
it must be known, the distribution of the stakes must be known beforehand.
No, so the
Right.
function says, yeah. So we give the median all the validators, but also the state. So I think I'm pretty sure I cannot. If you guys want to look at it, I'm pretty sure it's only the
Yeah, I'm trying
message.
to pull it up so I can just have it dual screen for you guys. Is
Yeah,
it in,
it's in that shared folder.
It looks like it's only
these-
messages that we've seen.
is it
It's
in
called
the
minimal CBC Casper. Oh, what page is this on? That's a good question.
Well, there's a table of contents that you can click.
synchronous
Oh,
bit
okay.
block?
So this is integer consensus, so 20.
So let me share my desktop here. Because there's a folder that I'm in. Which one?
So it's a drive folder called Casper Consensus POS.
Yeah, that's the one that I'm in now. Where do you grab that?
Yeah. It's the minimal CBC Casper draft. Oh, is it not in there? Hold on. Can you go down?
On stake.
Dude, that was
Byzantine.
supposed to share. What's wrong?
It
Oh,
should be
hold on.
CBC
I don't
Casper
know.
paper draft, but I don't know if you guys have it here.
Yeah, it's not in there. So looking at your screen, it's not in there.
Yeah. So
Does anybody know how
the
Google
repo,
like?
yeah, the repo is CBC Casper, so it's not in the Ethereum repo.
Yeah, sorry guys, sorry.
So if you
Apparently,
Jeremy, if you go to GitHub/CBC-Casper.
What the hell?
Yep. Just click enter.
Yep.
So if you download it, yeah. So you're gonna have yeah. You can just click on the integer.
Block
Yeah, yeah.
estimator.
The one
Oh,
with,
here it is.
yeah. Cool.
All right, cool. So let me post up this Word document real quick.
So now, does anybody know if this is true? So I shared the link with that folder, and I'm just adding things to it, but somehow the papers I'm adding to it are not there, and it looks like you only have access to the stuff that was in there at the time I shared the link. That just seems weird.
Yeah. Where is that folder? Is that Google Drive?
Yeah, it's in Google Drive.
Strange.
Who's
Yeah,
the owner of this folder?
I'm the owner of it, so that it seems weird that if I'm putting stuff into the folder, I'll look into it later.
Yeah, maybe you need to change the sharing permissions.
Yeah, it's possible.
Okay,
All right, so here we go. Can everyone see this all right?
Yeah.
So if we go to the 421, you can see that what we pass to the median function is a union of validators.
Oh, whose latest message is in our
State,
stuff?
yeah, justification.
Okay. Yeah, okay, so not the full weight then.
Yeah, so I think it's only the messages we've seen, kind of.
Okay. Cool. Okay, so then we're not considering Joe in this estimate then, only John, Alex, and Bob.
Yeah, but I think it still becomes number 9.
Yeah, right.
And like the empty set will be the one above it.
Yeah. Oh, interesting.
So, you mind if I just swap this one up a little bit?
Mhm.
So, I'm curious to know. Let's do this one. Where Bob is completely out of the equation, and we need to come up with the estimate for this.
Okay.
So now we just have Joe, Alex, and John.
Yeah. Yes. So I mean, correct me if I'm wrong, but from my understanding, we're only considering the weights from those 3 validators, John, Joe, Alex. We're going to look at all of the estimate values that they've proposed, so 1, 11, and 9. And we're going to do that calculation of the sums of weights, for each one of those estimate values and find the one that satisfies both of those properties. Is that right? Yes. Okay. Cool. So this one's really easy, right? Even, I mean, I guess they were all equally as difficult, but yeah. So for 1, nothing is strictly less. So how do we do that calculation? It's just empty, and so satisfies it just vacuously. Because the weight of validators proposing strictly smaller values is 0.
Yeah, so the way I think about it, so I just first find the sum of all of them divided by 2.
Yeah.
And then I line them up as a 1, 9, and 11.
Okay.
I put the weights underneath, and then I kind of see where is the middle set of values that anything above it is below the half of the sum, and also below it. It's probably it's easy because we just have few values.
But I thought it was anything
Right.
that's less than. I thought it was. Oh no, that's for the weighted. Never mind.
Yeah. Well, yeah, actually include that though, because that is our estimator right there. Or I mean, it's included in the estimator, right?
So looks like we're still stuck with 9 in this case, right?
Right. Yeah. So let's just run through the same calculation with 11 and with 9, right? So like one is not going to satisfy it because the estimates that are strictly larger than 1, so 9 and 11, they carry more than half of the weight, right? So 1 is out. Okay, cool. So then let's go to 9, since that's the next biggest estimate. So 9, the only value that's strictly less is 1. There's a weight of 1 for that, and that's less than half of the total weight seen, which is 13. So that's good. It satisfies the first condition there. For the second condition, the only value that's strictly larger is 11. That has a weight of 5. And 5 is less than half of 13, so it satisfies both, and we don't even need to check 11 at that point.
Okay, so actually, we do the median of it.
Yeah, so
because that's in 6.5, therefore it's automatically kicked out.
Well, so when we're looking at the entry, so we're looking at the estimate value of 9, right? And basically we're saying, does this satisfy both of those conditions? So we first check the estimate values that are strictly less. 1 is the only estimate value that's strictly less that Bob has seen at this point. So the sum of the weights of the validators that have proposed that value is just 1, because only John proposed that value. So 1 is less than 6.5, so it's good. It satisfies that first condition. To check if it satisfies the second condition, we look at all the estimate values that Bob sees that are strictly larger than 9. 11 is the only one that's strictly larger than 9. It's coming from Joe, who has weight 5. 5 is less than 6.5, so 9 satisfies both criteria.
Okay, so that's why 9 will win.
That's why 9 wins here, yeah. And of course we could do the same calculation with 11, but it won't work for the value strictly less, because there's going to be a weight 8 there, and 8's bigger than 6.5. Okay, I think I'm getting a handle of how you compute this, median stuff.
I mean, that's just a suggested estimator, right? We can do it the way we did it before as well.
Right. Yeah. I wonder how differently we can produce DAGs using those 2 different estimators. Yeah, but either way, it's like 8 after at this point, so I don't know if you guys want to call it here, and we can just continue from this point next time.
Yeah, that'd be great.
One interesting point for this kind of estimator is I'm thinking about that it might be vulnerable to attacks in systems where we have about a rotating validator set. Or maybe not about rotating validators, but at least say where one can choose the initial distribution of stake, or whether, I mean, if someone distributes a stake accordingly and is one of the same entity, then I guess he can pretty much force a value. I guess so. I guess this validator doesn't even have to have a lot of stake in the game. I'm not 100% sure, but I guess it's attackable in that sense, that if the stake of the initial validator set can be not modified, but can be chosen by the parties, I guess that might be attackable. It's just
wait. So just so I follow, because I'm not 100% sure I do. So what I'm thinking from what you were just saying is like if there's a bunch of validators with really small stake, is that kind of what you're saying?
What I'm saying is, what if Alex at the registration of the initial validator set splits up his stake in a certain way, or validator splits up his stake in a certain way that kind of gives an advantage in this
Yeah,
whole
so like Alex splits his single weight 7 node into 14 weight 0.5 nodes or something.
Yeah, maybe not
So
in this way, but I'm not 100% sure how he could change it, but that was the initial feeling I got once I've iterated through all these kind of estimates, that there might be something to consider regarding the
yeah.
initial distribution of the stakes.
Yeah, no, I definitely I get what you're saying, but now as we're like kind of talking through it a little bit, I don't think it would change much because the only thing they would want to do is like influence that value they're proposing, right? And no matter how they split their stake, that value only has a certain weight behind it, right? So like if they started with 7 as their weight, no matter how they split that weight, it only adds up to 7 unless they put more stake in, and I mean then that's a different story.
Yeah, but also consider that not every validator sees every message. So just from the assumption that it is just the it is just the weight of the validators in the justification, or from the messages the validator has seen, that changes a lot, I guess, because then it's just the stake from all the messages the validator has seen. So it opens up a lot of attack vectors, I guess.
Interesting.
But this is
Yeah.
just a feeling, and I really have to think it through. Just, I guess
Yeah.
there might be something, but
I'd like to continue talking to you about this because like originally when you said it, I was like, wait a second. Yeah, that's totally a weakness because we could just like multiply our your private key or whatever, just build as many key pairs as we want and distribute our stake amongst those key pairs, and then like just have 50 nodes where we used to have one, and we're all proposing the same value and kind of like flooding the network with messages. But I'm honestly no longer convinced that it would be an advantage. But this is something that we could talk about later if you want.
yeah.
That's a really
point
interesting.
is, the point here is that within this estimator, it just within the criteria, it just includes the state. The criteria is about the stake of all messages I've seen or are within my justification. So it just leaves out the whole the whole validator stake. So in that first in this current example, it does not include Bob's stake in this kind of estimator, and this leads to some attacks where one can force, or maybe to DOS attack some validators in order to force others to come to a consensus on your values. And I guess that's even a lot less than just coming up with those thresholds, which are quite no 1/3 or whatsoever.
Right.
Or 2/3.
Yeah. So maybe the I don't know, maybe naive fix is like, don't propose blocks unless you've seen a certain amount of weight voting on, you know, a value.
Yeah, but how to bootstrap this? No one starts proposing.
Yeah, right. No, that's a good point.
But again, I need to give it a deeper thought on this.
Yeah.
It's just an intuition there that this kind of might be attackable in some ways.
Yeah, interesting. Cool. Well, yeah, thanks for bringing that up, because that is a really interesting thing to think about.
Leave it to Phil.
Yeah.
Breaking consensus protocols.
Cool.
Well, I might be totally wrong here, but it's just was an initial thought when we went over the two examples. It feels like it leaves it kind of ignores for a certain viewpoint other validators, and in certain network topologies or network assumptions, but specifically when it comes to asynchronous networks, that might be some way to attack the protocol or the consensus procedure.
Yeah, totally. Yeah. So I guess now the next question is, do they have any sort of security proof in the paper that addresses this particular attack, right? Which I just don't know.
Yeah, I don't know either. But yeah, I need to think it more think about a little bit more about it. It just was just an initial thought.
Cool, man. I'd be more than happy to continue discussing it.